Welcome to qnawire.
Here the question is, the complex ion palladium complex is given is diamagnetic. Propose a structure of palladium chloride complex ion, and here the structure of the palladium complex we can understand only when we know what is the electronic configuration of palladium. Palladium is atomic number 46, and it is like nickel electronic configuration. Nickel and palladium both are in the same group, so we can predict electronic configuration of palladium. It is krypton, that is the nearest noble gas configuration, and after that 5s2 4d8. And here in this complex, palladium is at +2 oxidation state, so it should be 5s0 4d8. Now with this, the electronic configuration or distribution of electrons in the d orbital, according to crystal field theory, we know that splitting of the orbital is taking place. Lower d orbitals are these two and upper d orbitals. And these 8 electrons we have to arrange here. 1, 2, 3, 4, 5, 6, 7, and 8. One thing we have to understand, that is 1d orbital is vacant and this electron is shifted here for the pairing of electron, and by this electronic configuration only we can say the complex is diamagnetic because no unpaired electron is present in it. Very important thing to note here is hybridization is dsp2 and square planar geometry is present here. So palladium complex must be square planar with the 4 chlorine at the corner of the square, and this whole thing inside the big bracket, and the charge over it is -2. This should be the structure or geometry of the palladium complex. But the important thing, why it is so, when we know already that chlorine is weak field ligand, and because of that this electronic configuration is not understandable. This is due to actually poor shielding effect of the 4d orbital. This is common in higher d orbitals like 4d and 5d, and high effective nuclear charge of palladium, and because of that only this pairing is taking place. So we can give 2 reasons to explain this, that why in spite of chlorine as weak field ligand, palladium complex is acquiring a square geometry and dsp2 hybridization. The 4d orbitals of the palladium 2+ are more radially diffuse. That means palladium 4d orbitals are very big and diffuse as compared to 3d. They are very big, therefore, they form this strong overlap with the orbitals on chloride minus ion. This leads to larger splitting of the d orbital, and because of this larger splitting of the d orbital, this electronic configuration is taking place. Again, because of d orbitals are more diffuse, the pairing energy is much less in the PD complex, palladium complex. So pairing is taking place. Energetically, it is favorable. Together, these two factors ensure square planar geometry of the ligand of the complex, and even if the ligand is not the strong field ligand, it is weak field ligand, palladium is acquiring square planar geometry.